When you are sketching the graph of a polynomial, you need to figure out the x-intercept, the end behavior, the y-intercept, and then you'll actually be able to draw your sketch. Whenever I ask you to do this in class, I will have these steps written to try and give you a little bit more structure. Okay, sketch a graph of y equals x cubed plus 5x squared minus x minus 5. Let's start by finding our x-intercepts. You can find your x-intercepts by factoring. If we had a quadratic, you could also try the quadratic formula or completing the square, and you can also use long division. I am going to factor this by grouping. You should know how to factor by grouping at this point. Don't forget that now I have a difference of squares. I can square root this and end up with a positive and a negative. The pattern is to have 1 plus and 1 minus. All right, so now it's factored, but to find my x-intercepts, I need to set each factor equal to 0. These are my x-intercepts. Now let's talk about the end behavior. We need to talk about the degree and the leading coefficient. So my degree here, my biggest exponent, is a 3. That means the leading coefficient is the number with that cubed. There's no number there, which means it's implied to be a plus 1. So my leading coefficient is positive 1. It's positive, which means my graph is going to end by pointing up. The degree is 3, which is an odd number, odd and opposite. So since the right side points up, the left side's going to point down. So leading coefficient, degree. All right, last thing we need to do is figure out the y-intercept. So we can substitute in a 0 for every single x that you see in the original equation. If you type that into your calculator, I already did because I messed up in a previous video, so it's already done here for us. Perfect. You should get that your y-intercept is -5. And if we write it as a coordinate point, that would be our coordinate point. Okay, now let's put all three of these concepts together and draw our sketch. All right, let's start. You need to plot your x-intercepts. So I have an x-intercept at -1, +1, and -5. All right, now let's do our end behavior. The right side points up, so the rightmost x-intercept needs to point up. The left side points down, so the leftmost x-intercept needs to point down. Now you're going to connect your dots with nice smooth curves. Polynomial functions look like this. They're usually pretty curves like that. So that's all we're doing. Make sure you do not cross the x-axis at any spot other than these 3 points. All right, so from this first x-intercept, I need to cross through and go away from the x-axis before I come back down to the second x-intercept. Cross through and go away from the x-axis before you come to the third x-intercept. Cross through, and I connect to make my arrow. So yes, that looks super rough, but you do get the general idea. This is going to be a graph similar to this shape here with different x-intercepts, obviously. You can always type it into your graphing calculator to double check, but you should be doing these by hand without using a graphing calculator. Let's do another example. This one's going to be a little bit nicer because I have given you the original equation, but I also factored it for you. So when you're finding your x-intercepts, there's not a way for us to factor this. We would have to find our x-intercepts by using division, either synthetic or long. Luckily, I gave you the factored form, so now you just have to set each one of those factors equal to 0. So that was nice and quick. I figured out my 4 x-intercepts. All right, let's talk about end behavior. You can either say, this is my degree, my leading coefficient is positive, and my degree is 4, which is even. Or you can look at the factored form and say, oh, there's nothing written here, so that's implied to be positive, and I have all implied 1s on these x's, so 1, 2, 3, 4, my degree is 4. It's the same rules no matter which form you're looking at. So since my leading coefficient is positive, the right-hand side is going to point up. Since my degree is even, they both point in the same direction, so the left side will also point up. Now I need to find my y-intercept, so I need to sub in a 0 for all of my x's. You can sub it into either form. I like to sub it into this first form because all of these are zeros because they all have x's and your answer is automatically going to be 12. You can type that into your calculator if you want to double check. But if you sub it in 0 minus 1, 0 plus 2, 0 minus 2, 0 plus 3, you should also get a 12. All right, final step. Now let's sketch. So we need to start by plotting our x-intercepts. Okay, in behavior, the rightmost x-intercept needs to be pointing up. The leftmost x-intercept also needs to be pointing up. Now we are going to connect the dots in nice smooth curves. So as I touch this x-intercept, I need to cross through the x-axis, go away, and then come back to get to the next x-intercept. Cross through and go away, and then come back to come to the next x-intercept. Cross through the x-axis and go away from the x-axis before you come back, and you cross through and it matches up with my arrow. I don't know if I mentioned this in the last example, but let's compare our y-intercept here. I got a positive 12, and I haven't really been paying attention to my heights. That's not important, but it is important to notice this is a positive number where I cross the y-axis. So I probably did this right. In the last example, I crossed at a negative number, and notice we had a negative y-intercept. So again, that just confirms that we are somewhat on the right track.